Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. And yes, I gotta get back to you. Mathematics. We are continuing our quest for the knowledge of how to interpret, how to work with, and how to use sets and Venn diagrams. Let's get right back to it, shall we? Okay, so we have a Venn diagram here, and it illustrates the number of people in a sporting club who play tennis, represented by T, hockey by H, and determine the number of people in the club. Well, that's easy. We have a 15, 27, 26, and 27, so for part A, the total people in the club is everybody, and all we really know is who's playing tennis, hockey, and who's playing both. So I'm going to add up all the numbers. Don't forget those who we don't know what they're playing. Maybe they're just in the club. We add those up and we get 75 people. B, those who play hockey, that's going to be everybody within the hockey circle. So 27 plus 26. By my calculation, that is equal to 53. Could this be any easier? I don't know. Who play both sports? Well, that's going to be the intersection here. That's easy peasy pumpkin pie. That has to be 27. D, who play neither sport, that's this person right here, this thing. That would be 7 folks, don't play any sport at all. And then E, who play at least one sport, So these 27 play 2, but that's at least 1, isn't it? And the 15 and the 26, they play the one sport. So this would be 15 plus 27 plus 26. And that, my friends, is equal to 68. Could it be any easier? Probably not. Take a look-see right here. The Venn diagram alongside represents the set U, the universal set, of all children in a class. Each dot represents a student, okay? The event E shows all those students with blue eyes. Determine the probability that a randomly selected child has blue eyes. So first, let's see how many have blue. 3, 6, 8. So that's going to be 8 out of the total. And the total number of dots is equal to 23. You got to trust me on that one. So it would just be a chance of 8 out of 23. If we wanted to symbolize that, that's the number of students in the group E compared to the number of students in the universal set, which I told you is 23. Does not have blue eyes. Well, in this particular set of data, they either have blue eyes or they do not have blue eyes. So the probability of not blue eyes, maybe I should have said probability of blue here, equals probability of not blue eyes. Okay. Since these probabilities have to add up to 1, since it's just 2 things happening, E and E naught would be 1 minus E. I shouldn't say that. 1 minus probability of E, which would be equal to 1 minus 8 over 23, or 23 over 23 minus 8 over 23, which is equal to 15 over 23. Of course, you could have counted this up and just said, oh, okay, well, that's 15 out of 23. No big whoop there. All right, couple of more. In a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both of these subjects. Display this information on a Venn diagram and hence determine the probability that a randomly selected class member studies. Boys and girls, we got to do a Venn diagram, so let's do the circles first. Okay, so I've got that circle. I'm going to copy it and paste it. Let's have them overlap because we do have students here. Let's get it out of the way over here, I think. Okay, and we'll have it overlap here. Good, and then we need a universal set. So I'm going to go to the rectangle. There we go. And Okay, so now we have to label this, and oops, don't need that. So we have physics, we have chemistry, and we have our universal set. Okay, so what do we know? In a class of 30 students, 19 study physics, 17 study chemistry, and 15 study both. We got to start with the both, so that's 15, yes? If 19 study physics, I'm going to need 4 more here, and if 17 study chemistry, I'm going to need 2 more here, okay? Very good. So, how many study both subjects? Or no, what's the probability that they study both subjects? Okay. Oh, wait. Hold the phone, Chuck. What did we forget? Well, we have a total of, let's see, 19, 21 students, and there's 30 students total, yes? So that means if this is 21, there's 9 who study neither. Okay? 9 who study neither. Almost forgot that. What a loser I am. Okay? So, how many study both? Well, that's what's the probability that they study both? So, probability of both is going to equal 15 out of 30, what they have in common, or 1/2. Okay? At least one of the subjects. Well, at least one of the subjects, that's all of these folks. So that's going to be 21 out of 30. Oops, probability of at least one. So that would be equal to 21 out of 30, which simplifies to, come on, you know it, that's going to be 7 out of 10. Okay. What about C? Physics, but not chemistry. So these are all the physics folks, but we're only interested in those who study physics but not chemistry, so that's going to be these 4. So probability of P and not C, not chemistry. You got to be careful here. That is going to be 4 out of, it's not just out of these guys, it's out of everybody. It's out of all 30 students, so it's 4 out of 30, which is 2 out of 15. Megan Pappas has walked into the room, and she's trying to be quiet, and it's kind of creeping me out because she thinks being quiet, I guess, requires her to sit on the floor. Whatever floats her boat, I suppose. Say hi, Megan. Hi. Yeah, it wasn't loud enough. Okay. How many people, what's the probability that they study exactly one of the subjects? Well, we don't know what these 9 yahoos are doing, but we know there's 4 who study only physics and 2 who only study chemistry. That gives me 6 out of 30. I'm done writing this just to save time. 6 out of 30, and that simplifies to 1 out of 5. And letter E, last but not least, neither subject. Well, that's just this guy, isn't it? 9 out of 30, which simplifies to 3 out of 10. Not so bad. Okay. What else did I want to do? The other way, if we kind of reasoned it out, but if things get dicey, we could have labeled this section A, this section B, and this section C, and this section D outside of those sets. And then we could have set up equations like this. We know that A plus B equals 19. It wasn't necessary because these numbers were really easy. We know that B plus C has to equal 17. And we know that that B equals 15, and we also know that A plus B plus C plus D is equal to 30. Okay, so that's just a way to think about it algebraically. When they get a little more complicated, you can do that. Okay, so we need to verify using Venn diagrams that A union B naught is equal to A naught intersect B naught. Let's have a little bit of fun. We're going to do that using Venn diagrams. So here's our Vennies, 2 of them. Okay, and we need some circles. So let's go back here to circles, and we'll just do that. Okay, and then we're going to need 4 of them. See, 1, 2, 3. So here we go. 1, 2, 3, 4. What the heck are seats for? Sit the heck down. 1, 2, 3, 4. What the heck are seats for? I'm done with that. All right, so we have set A and we have set B. And we have set A and we have set B. Why 2? Because I'm going to shade what this one represents. I'm going to shade what this one represents, and they're going to be the same. So let's think about A union B. A union B is all of this stuff in here. It's all of it, 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 right? Oh no, but it's not. A union B not. So this entire thing represents everything outside of A and B. So what I really need to shade is all of this stuff, huh? All of it, but not including anything within the circles. I wish I had a joke, but I don't. I can't think of one right now that I haven't told you already. I'm thinking as I'm doing all of this shading. Here we go. Megan, you got anything for me? She's got nothing. Okay, so A naught intersect B naught. Okay, so let's think of A naught. A naught is all of this. Okay, it's all this. Everything that is outside of circle A. Everything. Ooh, look at that. I'm into part of B there, right? I'm in B mode, beast mode. Right? So I'm going to do that with vertical lines. Okay. And then with horizontal, and I'll get crazy and do blue, I'm going to do not B. So that's everything outside of B. So I can't shade anything or cross anything within the circle of B. Okay. So there she goes, just a walking down the street, singing do-a-did-it-dum-did-it-do, snapping her fingers and a shuffling her feet, singing do-a-did-it-dum-did-it-do. Done. Okay. So the intersection, where I have, I'm going to put a pinky here as well, where I have the intersection, and not just horizontal or not just vertical lines. That is the set that we're talking about. So if you look at that, that's everything outside the circles again. So using a Venn diagram, I have proven that A union B naught is equal to A naught intersect B naught. Was that a beautiful thing? I think that it was. I hope you enjoyed it. Let's see how the Electric Light Orchestra is doing as we say goodbye. I have done all, oh, it's not ELO. Let's see what it is. Oh, you too. I've done all the damage I can do here. I will see you next time. I am out!